We talked about Class A, Class B, and Class C networks and their differences. Now we're going to talk about how to set up subnets for each of these types of networks. To do that, I'm going to introduce the second half of the IP address. It's called a subnet mask. Remember how in Class A network the first octet always stayed the same? The subnet mask associated with the Class A network will always stay the same too. In a Class A network, your subnet mask will be 255.0.0.0. All the binary bits in the first part of the Class A subnet mask are ones. In a Class B network, the subnet mask will be 255.255.0.0. Just as the first two octets in a Class B IP address stay the same, so do the first two octets in its subnet mask. In a Class C network, the subnet mask will be 255.255.255.0. Just as the first three octets in a Class C IP address will stay the same, so will the first three octets in the Class C subnet mask. When you see an IP address, the subnet mask will give you a clue as to what the network ID is for the network you're working with. For example, if you have the IP address 130.178.130.200 with a subnet mask of 255.255.0.0, then the network ID that you'll be working with is 130.178. Because if the first two octets in the subnet mask are 255s, then the octets in the matching IP address will be part of the network address. This may seem pretty straightforward when we're talking about simple networks, but when we get to more complex IP addresses, this is easier to see when you do it in binary. This is how it's done. Compare the IP address and the subnet mask. Any bits that both have a 1 in them will equal 1. All others equal 0. See how the first binary bit in both the IP address and the subnet mask have a 1? That bit will equal 1. The next four binary bits have zeros in the IP address and ones in the subnet mask, so they will equal 0. Do this all the way across. When you're finished, convert the number back to decimal format and you'll have your network ID. Using this same network ID, the binary code for the last host that can have an IP address in this network ID would be 10.0.0.0.11.11.11.11.11.11.11.11.10. That means that the last IP address that can be assigned for a host on the network would be 130.178.255.254. You're probably wondering why the last bit is left as a 0, and why the last number does not end with a 255, but instead ends with a 254. That's because if they were all ones, then you would have the broadcast ID 130.178.255.255. The broadcast ID can't be used on a host because it's used to send broadcast messages to all the hosts on the network. Now that you have the network address for your network, you can start assigning IP addresses to your hosts. If we're using 130.178.0.0 with a subnet mask of 255.255.0.0, we can start filling in the blanks and adding host IP addresses. We never start with the 0 ID because that's the network address. So we start with 130.178.255.0.0. 192.0.0.1 and go up from there. We also don't use the last IP address in the network because that's the broadcast address. Since there are 16 bits in the host part of the IP address, this means there are going to be 2 to the power of 16 minus 2 IP addresses for the network, or 65,534 IP addresses that you can assign to hosts on this network. The host IDs that you can assign will go anywhere from 130.178.0.1 through 130.178.255.254. Class A IP hosts are similar to Class B, except that there are a lot more host IDs available. We're using 3 octets for the host IDs, that's 24 bits. To find out how many host IDs that would give you, we take 2 to the power of 24 minus 2 and end up with 16,777,214 host IDs you have available to distribute. For the network 13.0.0.0, you can use host IDs from 13.0.0.1 all the way through 13.255.255.254. A Class C network only uses the last octet to assign host IDs, so that would be 2 to the power of 8 minus 2, or a mere 254 host IDs. This one is much simpler to create and design than the others because you don't have as many octets to work with. If you're working with the network 192.168.1.0, you can use the host IDs 192.168.1.1 through 192.168.1.254, and that's it. You have now learned all the basics of subnetting. Before you move on to the next video, make sure these first 3 videos make sense. After this, we'll get into VLSM, CIDR, route summarization. If you have the basics down, you'll breeze through these lessons.